Hey, welcome to The Explainer. Today we're going to break down a really core concept in the world of AI. It's called supervised learning. So let's just jump right in. Seriously, think about that for a second. What if, instead of all this complex code, you could teach a machine just by, well, showing it thousands of examples? You give it the question and the right answer over and over again, and it just figures out the pattern? That's the big idea we're going to unpack today.
And that brings us to the official term for this whole process, supervised learning. Now, the phrase you really got to latch onto here is labeled data. That's our answer key. Every single piece of info we feed the machine already has the correct answer attached to it. So you see, we're not asking it to guess in the dark. Nope. We're showing it exactly what a right answer looks like from the very beginning.
And that's exactly why we call it supervised, right? The labeled data is basically the teacher, guiding the student, which in this case is our AI model. It's kind of like when you were in school practicing math problems. You'd solve one, check the answer key in the back of the book, and if you got it wrong, you'd adjust your approach and try again. The AI model? It does the exact same thing, just, millions of times faster.
All right, section 1, sorting versus predicting. So what kind of subjects can our little AI student actually learn? Well, it really just boils down to two main things: sorting stuff into different groups and predicting specific numbers.
Okay, so let's break those two down. On one hand, you've got classification. Its whole job is to predict a category. Think spam or not spam. It's a clear choice between a few options. Then on the other hand, you have regression, and that's all about predicting a number, like the exact price of a house. So yeah, one sorts, the other predicts a value. Simple as that.
So let's talk about classification in action, sorting data into boxes. The questions it answers aren't always about belonging to a group, right? Is this email spam or not spam? Is this a picture of a cat or a dog? Did this student pass or fail? You see the pattern? The answer is always one of a handful of fixed, predefined labels.
Yeah, and this quote really nails it. Think of classification as choosing a box to put data into. That's literally all it's doing. It looks at a new piece of data and says, okay, which box does this one belong in? It's a super powerful sorting machine when you think about it.
All right, now let's flip over to regression. This isn't about sorting into boxes at all. This is all about answering the question, how much or how many? So we're not picking a category. Instead, we're trying to predict a specific point on a sliding scale, like what will a house sell for? What will the temperature be tomorrow? What's a company's stock price going to be? It's all about the numbers.
Section 2, from training to test A. Okay, so we get what it can learn, but how does it actually study? Let's take a look at the AI's study plan, which is basically the standard workflow for any supervised learning project. So here are the steps. It all starts with step 1, collecting all that labeled data. That's our textbook and our answer key. Then, and this is super important, we split that data up. After that, we pick an algorithm, which is kind of like the learning strategy. Then we train the model, test it on brand new data it's never seen, and finally, we grade it. We evaluate how well it did. And I really want to hammer this home. That split between training data and testing data is absolutely critical. The training data, that's like all the homework and practice questions. The model gets to see both the question and the answer, so it can learn the patterns. But the testing data, that's the final exam. It's totally new, unseen stuff. And that's how you prove whether the model actually learned the material or if it just memorized the answers from the homework. And look, this stuff isn't just theory. You're using supervised learning every single day, probably without even thinking about it. That email filter that catches spam, yep, that's classification. Your phone recognizing your friend's face in a photo, also classification. A bank looking at your financial history to approve a loan, you guessed it, supervised learning. It is literally everywhere. All right, section 3, the supervised report card. So let's grade this thing. Just like any student, supervised learning has some real strengths, but also some big weaknesses. It's super important to know both.
Let's start with the strengths. First off, its accuracy can be just incredible. I mean, if you give it good data, it can be so precise. The results are also usually pretty easy to understand, and because it's been around for a while and is so well researched, it's become a really reliable tool for solving actual, real-world problems. But, and this is a big but, there are weaknesses. The biggest catch is that it completely depends on having that labeled data. And getting all that data ready, it can be so time-consuming and super expensive. And here's the most critical part. If your data is bad, or biased, or just plain wrong, your model will be too. It's that classic saying, garbage in, garbage out.
Okay, section 4, your final takeaway. Let's wrap this all up. If you only remember a couple of things from our whole chat today, make it these.
So here's the core idea. First, supervised learning is just learning from examples that have an answer key. That's it. Second, it's got two main jobs: sorting things into categories, that's classification, or predicting numbers, that's regression. And third, and honestly, this is the most important one, the quality of your data will absolutely determine the quality of your model. Period.
And this final quote just says it all perfectly. Supervised learning is like learning with a guide. The more examples you see, the smarter you get. It's so powerful because really it's just mirroring how we humans learn. If you have a good guide and you see enough examples, you get smarter. We can teach a machine to become a real expert this way. Which, of course, leaves us with one very big question. What are we going to teach it next?